right, good thing I didn't do anything important yet. All right, now take a deep breath. I feel like I was out playing in traffic and someone pulled me back and was like, stop it, you're playing in traffic and without a life preserver. Okay, so the 2 topics of today, for those of you on YouTube, I'll go ahead, or the 3 topics. We have the Ask Me Anything, because your project is due, the blend trees that may make your life easier if you haven't done animations yet and you're doing some sort of character-based, or you're moving your character around the screen, and you want it to be responsive to motion and make the animations go in a lot of directions. I have to admit, I kind of forgot about these, and I was like, oh my God, I didn't talk about blend trees. So we've done it. The more, if anything, if you've tried to do the animations and transitions and so on, you've probably learned a lot more about transitions, which is a good thing. That is a good thing. But now, once you see blend trees, when you're doing this typical, kind of the easy, straightforward up, down, left, right animations to characters, hopefully you remember that there's such a thing as blend trees. And I'll talk a little bit about 2D lighting today, just to whet your appetite on it. Now, like I said, you don't need to add anything. You don't need to change the way you're doing anything, but maybe if you're having difficulty, maybe you'll want to check this out with regards to the animations. I did post a video specifically about blend trees without any talking in it. So if you're looking to save some time, or you want to review rather than watch this whole lecture again, you might just find that one video in that newer playlist. And I think I have a 2D lighting one that's just that in the playlist as well, but figured I'd mention it in class. It's a good thing to know that. All right. I hear some typing, which means maybe you can't hear me somewhere, or it's a hot mic moment and someone's just typing on their mechanical keyboard. Right, Ken? Okay. Just having fun. It's one of those days. Here's today's, today's mug of the day. Gotta have the mug of the day. I blame Mrs. Amherst for this. This is one of our Easter mugs. Love my peeps. Big fan of the marshmallow peeps. And anyway, that's the mug of the day. Okay. So let's get a screen up and talk about these things. Now, actually, first, before I do that, I had a request, and I like to fulfill requests. So you can always, and we can do this throughout the rest of the semester as well, especially because we've covered so many of the ground topics already. If you have something like last minute, like basically, if we have class on Tuesday and you have a question, say after 8 p.m. on Monday, throw it out there. Or if you have a question after 8 p.m. or 5 p.m., 6 p.m., whatever on the day before, throw it out there and I'll try to cover it in class. This way, if there is a technique that you want to see, we can do that. So this was a request this morning. Won't say it's from who, but the idea, and this is a useful one, the idea here is, imagine you're spawning an object, or you're spawning the player, or something happens, and you want, say, there's a grace period of stuff that happens, right? So what I mean by a grace period, let's see. Now I kind of want to, can I get no, my camera's just not going to behave. Let's see. Why is that? I feel bad that you can't see me. All right, I just keep going with it. So imagine the player, this is the behavior. I think I got the behavior down here. So the player comes into being, and you'll notice right away the player can actually walk through walls and objects, and but then all of a sudden now the player can't walk through walls and objects, right? So there's a moment where during the sort of the birth of the player, that one I can still walk through. That's kind of interesting. That must have its layer kind of overridden. Let's fix that. So let's check our ball sprites here. Ball sprite is on the ground layer. That's on the friendly layer. That's on the, okay, so that one must have been overridden. So we'll put that on the ground layer. Okay, try that again. You'll notice that the player can move around and move through objects. Oh, and that was bad. He got stuck inside there. That's one problem. So it sort of materialized and he was stuck in there. That's a bug to fix. So that's a cool thing. All right, good thing to happen, maybe. So how do we do this? How do we have this sort of delayed activation? Now this comes also back to like, when should I use coroutines and when should I use invoke? So both, obviously, we kind of spawn a new thing, a new task, a new, does something separate from our normal unit of execution. But coroutines, you got to remember what they are is they're designed around this idea of this incremental execution of code, right? So if you have like, you have a loop, or you have, something needs to happen, then something happens, then something happens, then something happens. And all along the while, you can sort of interrupt it, or you want to allow it to be interrupted. That's the go-to for coroutines. That's why they're because you have those yield states. Now, if you have something you just want to have happen, boom, one shot, then, maybe you go ahead and invoke, right? Invoke just means, okay, do it at this time or do it at this interval. And, there's no reason not to use invoke for that sort of thing. So for this kind of thing, immediately I think, well, I'm going to go with invoke, because what I want to have happen is basically the collider for our player is going to be disabled during startup. And then I'm going to have a routine, a method that's going to be invoked after some amount of time to turn on that collider, right? And this is also one of the situations you have to start thinking like this as you're developing games. You have to start thinking about kind of optimization and avoiding lots and lots of checks in your code. And what do I mean by that? Let's see. So in here, I could do something where I say, well, okay, for the first 5 seconds, let me check in my update loop. I'm going to say, oh, have 5 seconds passed? And if so, allow for a collision. Or maybe in my on collision enter 2D, I check every time to see has time passed, right? So I'm doing this kind of check every time this occurs. And if there's any way you can avoid a check, like we like to avoid logic whenever we can, right? If you got to be careful because you can overdo it as well. It's a double-edged sword here. But if we can avoid something, just have it boom, happen once, the logic takes care of it automatically. We're not pulling, then that's a way to sort of optimize things. So this is the collider on and off. That's a one-shot deal. So in the start, for the player, for the new hero controller, the only thing I really do here is I say, okay, I get the component, which is the collider 2D. Now, it doesn't matter which type of collider 2D it is, right? It's just a collider 2D. And so it'll say, well, if it's a circle collider, if it's a box collider, or if it's a capsule collider, doesn't matter. It's just going to get any collider 2D. And importantly, it's going to get the first collider 2D because I'm only asking it to get a single component, right? So if you have more complex situations, which I kind of do on this one, where I have multiple colliders on the player, I might need to get fancy, but in the normal case where I just have one collider, that's probably what most of your cases are, and I just want to turn it off, I just disable it. I just say .enabled equals false, right? So that is disabling the component, right? I'm not deleting any objects. I'm not, nothing like that. I'm just disabling that component. And then I spin up, I just call it a little invoke that says, okay, after 3 seconds, I call my reactivate hero method, which is just down here. All it does is it says, okay, get component collider 2D enable equals true. So it goes ahead and turns on the collider, right? Now, you'll notice I had that weird situation where I wound up casting my poor, or my hero wound up being locked in a wall there, right? Why did that happen? Well, we basically enabled the collider while it was inside of that other one, right? So then suddenly all of the physics collisions kind of came into play, and that was potentially bad. So This is the extra bonus case. Maybe you need to do this. Maybe you don't need to do this. This is sort of the defensive programming as I'm thinking in my head. I might want to do something in here to be careful. Don't enable that collider if I'm inside something, if I'm colliding with something else. Wait until I'm not colliding with something to actually enable the collider. Does that make sense? Right? So if I'm not overlapping something, I want to wait for the player. I'm going to give the player an extra grace period to say, don't do that. So now I've got to be a little bit fancier. All right. So this suddenly might be a case, well, maybe we should have used a coroutine, right? Because now I'm going to be checking something. This might require yielding some time to wait for the player to move outside, right? So let's go ahead and say that I enumerator. So we're going to use that. That's our key to a coroutine, right? Void, and we'll call this, we're going to substitute out reactivate hero co. We're going to call it that, right, for the coroutine version. What did I do? Okay, am I doing this wrong? What am I doing? I'm forgetting my coroutines. What I always like to do is I just grab another example of them. I call up my generic fade, and I say I enumerate. Okay, it's just an I enumerator. All right, just to remind myself. So here's how we would start a coroutine. So I'm going to just say, all right, yeah, I'm going to cheat. I'm going to grab some coroutine code from somewhere else. Be careful. Be careful when you do this. If you do this and you wind up leaving junk code around, you don't want to do that, right? So I just wanted to look at this for a second here. I'm even going to sort of be careful and comment it out. I should have just done a split screen. That would have been a smart thing to do. So we're going to have our start coroutine here, right? And this is going to be for our reactivate hero co, right? And we have our I enumerator for reactivate hero co. And it's just complaining about, return paths. So we'll do this. We'll just say, let's start off our coroutine. Now we'll get rid of all this other junk that we don't need because we have enough to remind us how to do this, right? All right, so now we have a coroutine called reactivate hero co, and we can start it there, right? And the goal, of course, of our reactivate hero co is to eventually get to this point and to enable that. So that's the goal, the same thing. But we need to check some stuff before we're allowed to do this, right? So now we've crossed over the Rubicon, the river, whatever it is, crossed the Rubicon, crossed the chasm, said, okay, we now need a coroutine. So why? All right, so we're going to say it could be a do while, right? Could be anything in here. And the idea is, what I want to do is I'm going to use our friend, and I will call, this is going to be a raycast hit 2D, right? There's the hint. We're going to use a cast to see, okay, when the player comes back in the scene, where we are right now, is that a safe place, right? So I'm going to use an overlapping circle, right? So hit equals physics 2D. We're going to use a physics 2D dot overlap circle. Okay. I like overlapping circles. I'm going to use a point. I'm going to use a radius to see, do I overlap anything in there, right? So I'm going to use transform dot position and a radius of, say, a radius of 0.75 should be plenty, right? So that's going to tell me whether or not, let's see, I cannot convert from a collider 2D physical circle, what happened here, to a Unity engine. So that's going to return a collider 2D. What I hit, I'm going to use that before. Check spawn. I used, oh, I just returned. No wonder I did that. That was my, so I just checked it. I didn't even bother. All right, so let's go back to that one. New hero, we're just going to say, we're not going to use the return value. We just want to use it as a Boolean, right? So this will tell us if that's true. So we could say, while this is equal to false, right? And what are we going to do? Well, it's going to yield return, wait for a certain amount of time. We could yield return null. We could yield return, it would depend. If we just wanted to wait for the next update, we could do that. But that's what we'll do. We're just going to wait in that loop until this, while this is true, keep doing that, right? So it's going to wait in here as long as we're colliding with something, we're overlapping with something. And the moment we're no longer overlapping with something, then we will fall out of here. That's the plan, at least. All right. So let's do that. I'm going to put a breakpoint in here because I like to, is the moment I get into a potential infinite loop situation, even though this is in a coroutine, I think it's going to be good. I like to just start debugging, right? Say attach to Unity. And all right, we're attached. We're good. We're going to go back to Unity. And we're going to go ahead. And if all goes well, I should check for errors in console first. So this is the fancier version. Like I said, maybe you have a scenario where it doesn't matter. You're not going to, collide, or you're not going to do anything. Play. And okay, I hit it already. So I started that coroutine and I am here. So what happened? What did I hit? Let's see. I'm violating my own rules here now. So I'm wandering around and I'm okay. 3 seconds pass. Must be the other way around. Either that or I'm hitting something all the time, which is possible. Let's check. I mean, I'm potentially hitting anything. Oh, one of the things I'm potentially hitting is myself. That's a bad thing, right? Casting a collider, I might have a collider on me, which I collide with, which is obviously no good. So I'm going to be worried about colliding with what? I'm going to worry about colliding with specifically the boundaries, which are the walls. I don't want to collide with the walls. So let's go back to our code and say, let's worry only about collisions with the walls there. All right, so layer mask, that's what I want to worry about. Now I want to say layer mask dot get mask. And we're going to look for walls. All right. So while I'm hitting a wall, do this. Right? That should be much easier to deal with. Let's see if we hit that. And here we go again. So if I immediately hit that breakpoint, I can start to wonder, why am I doing that? Okay, nothing happened. And I'm good. I wasn't in the wall. Nothing happened. So let's try to go in the wall there immediately, right away. We're going to run into the wall. Come on, Unity. I run into the wall. Oh, I know why. You know why it happened immediately? I don't have a delay, right? I have no delay whatsoever. So immediately it turns the collider back on. It just drops in here, boom, done. I need that initial delay of 3 seconds, right? So the initial delay that I have here in my in my invoke, I need to get that behavior. Okay, so now my coroutine, I say, okay, delay for 3 seconds, meaning I can't collide with anything during those 3 seconds. Then I start checking for that overlap. That's better. I think that's better. Let's see. Oh, Unity. All right. So I'm going to immediately run for the wall here. What happens? Run for the wall. I'm in the wall. Now, after 3 seconds, let's see, it worked, didn't it? So normally I'd wait. Ready? Here we go. We did it. It'd be really weird if I get stuck inside of the beach ball. 1, 2, 3. Now I can't hit the wall. Let's try it again. We're going to run into the wall and wait in the wall. Ready? And 1. When we go blue here. 1, 1, 2, 3. Okay, I'm hanging out inside the wall. And now if I went over to my Visual Studio even, and I said, okay, let's see. Am I not attached? That's weird. So I'm sitting there. This is happening. I'm surprised that this breakpoint isn't being hit. But I come out and it works. So it works, but I'm wondering if that's because that breakpoint is in a coroutine. Worked the first time, didn't it? So my logic is working, but my breakpoint does not seem to be. All right, but anyway, let's not spend too much time on the debugging of it. But the logic is there, right? The idea is that we go into our reactivation code here, we wait for the 3 seconds, and we're all ready to re-enable our collider. But as long as we are colliding with that walls thing, we sit here in this loop, right? Waiting for that to not be true, in which case then we can go turn on the wall, all right? Or turn on my collider, right? So I can even, actually, let's watch it a little bit closer. We can watch this happen. We're gonna go over here and go to the hero. And as the game starts, we'll see. I'm gonna run in there. Watch this box collider over here. That's the one that's gonna get turned off. All right, so watching that little check mark right there. Okay. So the check mark is not being turned on because we're in that loop. And as long as I stay in there, I'm cheating my way around the world here. I'm hiding from the treant. And then the moment I come back in, you'll see the box collider got re-enabled. Okay? You get a thumbs up. That makes sense? All right. So that was the one request I got. If there's any other requests, let me see. That is okay. That's a question about something that's not in this class. Sometimes I get questions during this class that are from another class. I can't cover those. I'm not going to jump into doing a vertex shader in the middle of this. That'd be crazy. Okay. So if you have anything to shout out, if you have any questions about your collisions, your colliders, that's one of the big things. Managing your colliders is always like, oh, I think I'm colliding with this. I'm not colliding with that. Something's not happening. Something's happening. And probably the way to make that easiest, to make it easiest to deal with colliders is always remember anything that's affecting the object itself. Like if you need to delete an object in reaction to a collision, do that in a on collision enter 2D that is on a script that's on that particular object. The more you try to, the player runs around and the player hits this and deletes that and so on. It's best to have those objects themselves take care of it, right? So it's bullets, for example, right? So say I have these arrows that I shoot, right? Some people will say, oh, how come my arrows aren't disappearing, right? So let's do that. So you'll notice arrows hit the wall up there, they don't disappear. Arrows aren't disappearing at all, So how do I make it so that the arrows disappear? Now I could put a collider on this, or an on-collision, behavior on this, a script on this, a script on that, script on everything. The best thing to do in that case, if I know that whenever an arrow hits anything, it should be deleted, well, that's best to put that behavior on a component on here. Now, I haven't done that yet because it's suddenly, you're like, all right, at what point do you decide, right? You'll notice there is no arrow behavior here, right? I'd avoided that, but now it's time to say, okay, we could maybe have something generic. That's destroy on collision. So make something generic, right? Say, okay, this script is all about if I collide with anything, destroy myself. So maybe it should be self-destruct on collision. Right? So we'll create that script. Should be more careful about where I put scripts, I know. But let's put it on there. It's probably just in the root of my project, like everything else. And so I'm going to go in here. I'm not going to need any of these. I'm just going to say on collision enter 2D destroy game object. So now this says anything I put this on, if it collides with something else, it goes away. Right? As long as a collision is allowed, it goes away. This will tell me immediately if there's a collision going on between the player and the bullet, by the way, because if that is true, then that will immediately disappear. So let's see. Probably have my layers set okay, so it's not a problem. So now right, that feels a little bit better. Don't have weird arrows bouncing off of things that don't make sense to. All the collisions are cool. You can bounce beach balls around by shooting at them. Okay. And the key to like the player not blowing up while it collides is that, of course, the hero is on the friendly layer and the arrows are on the player bullet layer. And if we look at the project settings, physics 2D, we'll see that the player bullets are not allowed to, or it's totally fine for them. They do not collide with things on the friendly layer, right? So that's why they don't blow up. If I had, say, player bullet and friendly, I'd have potentially a problem. Because then as soon as I shoot, well, I guess you notice it let me get one out. Why did I let one? And look, I even killed myself, right? This is the sort of thing that you run into, right? The player is colliding with his own projectiles at this point, right? So you got to be careful about that. We go in here, we say, okay, friendly things should not collide, or player bullets should not collide with friendly things. Player bullet, friendly, not a collision. Go back, and it's all good. right? Now, when you have things where you're like, okay, well, the player bullets, they shouldn't collide, but they should cause the player to bounce around and, whatever. Then you start to get into like, you want to check for tags and you want to do that sort of thing. Oh, I've got a cool hack for you. And this will, if you do this in your project, you will show that you're paying attention. We talked about once upon a time with tags, right? Tags, we kind of give them a bad rap. I like to come down on them a little bit weird because the problem is in tags, for example, the player tag here, the player's untagged, and I can only choose one tag here, right? It's kind of like I can always say, is it an arrow? Is it a power-up? Is it a friendly, enemy, ground, whatever? All right, so I'm going to say, all right, let's tag it player. And suppose I wanted to have some specific behavior to that, but then I had, like in my other game where I had another, we're going to create just a random thing. Yeah, you're all, see, until you ask questions, I'm going to like throw out crazy things. We're going to create a sprite. We're going to put this bird hero into the scene. Oh, and you're saying to yourself, why is that bird hero black? Let's not worry about that just yet. We need to change that to that. All right. Not quite right. Not a default line. He should be sprite. There he is. Normal sprite material. All right, so it's a normal sprite. And suppose that was the other player. And I said, well, I want to have another player. And so I add, and I can add any number of tags. I'll call this player 2. Okay, so I have player. I thought I had player. Where'd player go? Hero is player. Oh, there it is. That's weird. And bird hero is going to get tagged with player 2. Now, I could, in my code, say in, I don't know, I'm going to need to do this in maybe it's in, for the heck of it, in ball and initializer, just because. On collision enter 2D. And for now, let's just do this. Print collided with. And I'm going to say collision dot game object dot name. All right. And I'll also say tagged with. Just tag there. Game object tag. All right. And I have compare tags, so you can say compare it to this, there, that, the other thing, right? So let's see that happen. And see, this is the difference between game programming and just programming. You like learn clever. You have to learn to be clever. You have to like do crazy things, do interesting things. So now, if the player collides with a beach ball, we're going to see something on the console, right? Collided with boundaries, collided with the player. Player was tagged. Let's see, we're going to run over, find one of these things. There we go. Collided with hero, tagged with player, right? So then if I collided with my bird hero, I have to add a component. I would say call that a circle collider, or else it's not going to collide at all. All right, so now we have a circle collider on there that you can collide with. But we have player 2 and we have player. So we want to be creative, and we want to say, well, I don't want to check. I don't want to say if tag this, if compare tag that, and so on. I want to print this collision out only if it's either Either of those things. It could be the player or it could be player 2. Now I could check each one, 2 checks, right? Or I could do the following. So my first thing I would say is you'd probably think of compare tag, right? And you pass in the tag. Or I could say tag dot, and this opens up a whole world of craziness. You'll notice a tag is just a string. And that opens up all of the things that strings can do. So I could say contains, even just play or player. So now any tag that contains player, whether it's player, player 2, player 3, player 4, player unknown player, the masked player, and so on, it will pass that test. So we'll go back to the game. We should see now not all of these things going on, but we should see, give us our second here, right? All the player 2 and player collisions happen, right? So even though we can only have a single tag on each game object, you can actually do potentially some interesting things. Now, comparing, going in a string and actually, you know, doing a contains is a bit more of an operation than just a simple compare. But you can imagine now I could add yet another player, right, without changing that code that had its own distinct tag. But, you know, it could be like, all right, this player or player 3 or certain types of enemies you might want to react to, like a generic enemy. Oh, okay, we collide with it. But if I collide with that enemy, maybe I do something more specific. Okay. So it's yet another way to kind of exploit the fact that these tags are just strings, right? Gotta think of situations like that. So I don't know what led me down that path. The idea that we had kind of another tool to help us manage collisions potentially. All right, so let's go back to 2 other things I wanted to talk about. Any good segue now? Got a question? Ask it now, quick, before I jump into the other one. All right, you missed it. I'm going to talk about blend trees. So let's do this. Let's assume we have our player, our hero, and our hero has an animator on it, right? May very well have an animator on it. And we'll see that, okay, in here, our hero already has a walk back, walk front, walk idle, and walk side, right? So the typical, let's see, I think I have another hero controller. Which one is this? I guess I'll just jump to it. Oh, so for that contains, it works for any tag with player in the string. That's exactly right. Yeah, because it contains that substring, right? It's a way of searching for a substring within a string, right? So it's kind of cool, potentially a fun exploit. I've gotten past about 7 versions of this class with, that means probably about 150 to 200 students, and no one has ever needed to do that. So do you need to do that? Who knows? But it's always having that extra, looking for that extra quiver. Hopefully it doesn't become like, oh, I've got, you know, now I've got a new hammer. What's a nail? You know, you just go around pounding everything. But it's kind of, you just discover these things. That's why you have to always be trying different stuff. Don't do exactly what I say. always say, well, okay, how could I, what else can I, how does that work, right? That's the key thing, because Unity is, like I said at the very beginning of this class, Unity is going to change. You're going to wind up using Unreal Engine. You're going to wind up using Godot. You're going to write your own engine, all these things. The actual game engine you're using is always going to be changing, but some of the concepts and your ability to look at that and say, okay, how does that work? How can I use that? How can I take advantage of that? That's going to be the key thing that you need. If you walk away with nothing else, then that's that sense of inquisitiveness when it comes to looking at how these things work, right? You have to be able to do that. So, all right, got me distracted again. All right, so we've got this new hero. It has a hero controller and the animator, the normal. Everything looks normal so far, but I'm going to open up the animation. And our animator here, our state machine, looks very, very different than the typical state machine, right? You probably expected that one where we had the on entry and just the normal kind of stuff there, right? And maybe you expected something that looks like this, right? This is what you normally have. You have your walk front, walk back, walk side, walk idle, and then you have to decide, what's what, what's where, when, how does all these things work, right? But if you right click, you'll see you can create a state, you can create an empty state, then you can populate all these things by hand if you want, and you can even do things like say, I want a custom version of walk side. I could create an empty, and then this would potentially, I could put my, let's see, I have my walk side, put that in there, and so on and so on. It could create custom states, and this will be called another walk side. And for a lot of animating, you can get past without ever having to create a state, because the moment you create an animation clip down here, it creates a state in there, and you just go ahead and use that, right? It doesn't dawn on you to right click and see what else can it do, but that's what you need to do. You need to always be trying different stuff. So a very powerful thing in here is not the state, but this actual blend tree, right? So say from new blend tree, right? So you create this kind of magical state called a blend tree. And if you double click on it, it'll take you to its own state window here, its own diagram, which starts off just having a blend tree node on it, right? And now we can sort of configure what we want that blend tree to do. And with the blend tree, the idea behind a blend tree is that it can automatically take care of blending different animation states. And you might think, well, my little sprite animations are not really going to be blended, but they potentially are, right? You have a left, a right, up, down, depending on what horizontal and vertical, what these parameters are set to, you might want to blend. And especially as you get, more sophisticated animations, you might use this as well. But for now, let's say, all right, we've got our blend tree, and I click on that, and you can see some parameters for it. First off being this blend type. And by 1D, that just means there's only one parameter that can change, and I can make decisions sort of based on that parameter. But the more interesting ones are, say, 2D simple directional, 2D freeform Cartesian, 2D or directional 2D freeform Cartesian. Now for this, I think I'm going to use freeform directional, and I'm going to tell it that I'm going to use both the horizontal and the vertical, right? So you can see horizontal and vertical potentially coming in here, and I want something to happen as a result of that. So now I can put in motions. So add a new motion field that might be, all right, walk back, right? And I'll add another one that is walk front. Now, what I need to say now is say, all right, you'll see this little kind of chart in here that I can move around in, and it's showing me what can happen. So horizontal is now mapped to sort of this direction here, and vertical is mapped there, right? And what I can do is I can position these nodes that say, okay, where is that animation within this space, right? So this is walk front. So walk front should happen down here, and walk back should happen up here, right? And then as I am walking down, walking up, I should change between the two. Now, if you were watching down here, let's see if I can do this. Yeah. Watching down here, you'll see automatically as I move up and down, it's switching between those two animations, right? So it's basically saying whoever is closer, I'm going to make this 0 just to tighten up here, tidy up, 1, -1. Whoever I'm closer to, that's the one I'm going to use. All right, so there's my up, there's my down. And you'll notice I'm not really using horizontal for anything yet. But what I can then do is say, all right, let's add a new motion. And this is going to be walk side. And I'm going to create 2 of those. I'm going to create 2 walk sides because I don't have a left and a right. All right, so we'll add another motion. And we'll call this one walk side. And it's going to be opposite of X and Y, or opposite of up and down, right? So now, if I'm moving in either those directions, I can decide which one, right? So I go forward, backward, left, or right, automatically according to how this is changing, right? No transitions necessary. The blend tree takes care of those transitions for you, right? So let's go to the other one. I do already have redefined or already defined. This one's a little bit more sophisticated, but the same idea, right? It's the same idea where I have walk back, walk front, walk side. And I also, lo and behold, at the middle, I have idle. Right. So as I get to the center, it will automatically also go to the idle state. That's right. I can put as many different things in there as I want. If I had a diagonal walk, I could put that in there. Right. So I could do things like location in there made sense with regards to that mix of horizontal and vertical. And I can go one step further. You'll notice here, this is one of the walk. Let's see, which one is that? I moved this one, walk side, accidentally. -1 and 0. And there are some nodes that are kind of further out here, which are at 3 and -3 to the sides. What are they? Well, they're just the same walk side animation, but this other column is different. And what this other column is the speed. So I can increase the animation speed, basically interpolate, right? Well, it always comes back to interpolation, right? That's the key to life. So as I move out here, I'm getting closer to this node, which happens to be the one that says, okay, I'm still playing that walk side animation. That's the actual motion I'm using. However, the closer I am to it, I'm going to change the speed to 1.5. So the animation is actually going to play faster as I reach that value of 3. Right? Now, it turns out here it's just sort of arbitrarily showing me between -5 and whatever. The speed that my character actually can walk in is set according to the. Let's play. Probably didn't even notice that was all happening in here. So he moves up, he moves down, he moves left, and see, it kind of speeds up. It's kind of subtle, but it gives it a real fun kind of personal feel to it, right? So now you'll notice the all the delays, all the weirdnesses of, you know, managing the transitions and all that, they kind of just automatically took care of themselves. So you didn't have to worry about, oh, did this happen there? Was there an exit time? Was it whatever? That's another nice thing about the blend trees. It just sort of, again, automatically takes care of it for us. Oh, you'll also notice I added a feature. If you're looking for inspiration, a lot of intelligence or inheritance or anything like that, me here being angered, right? This is the normal following, right? It sees me, it follows me around, and if I duck behind a beach ball, or I duck behind something, try to duck. Ah, there. Oh. Chasing, but he's all right, far enough. Shoot an arrow at him. He gets angry and he starts to shoot arrows, and he also moves a lot quicker. It's a simple thing where I'm not just destroying an object immediately. I'm not destroying the enemy immediately. I have some hit points for him. It says, oh, okay, I was hit as a result of a collision. Now I'm going to get angry and change my behavior. And I think I showed that that was in one of the, actually basically everything in here is shown in that new playlist that I posted. So that's another fun one. If you're looking for, you know, just think logically through how would you do that? Set a flag, change the behavior, change the acceleration, change the speed. And the other one is the power pill, which is added the power pill. I saw a lot of hits on my YouTube video for that. So I assume everybody went out and looked at that one immediately. So here we have the power pill, and we're going to behave like Pac-Man. And we're going to let this treant follow us. And the moment we're going to eat the power pill, and immediately the enemy changes, it wears off after a certain amount of time. Right? There's I think that's just an invoke that I used to say, oh, wait a certain amount of time, and then change my direction back, right? I'm scared. I have a scared flag in my enemy here. Chase. That becomes really important to get that power pill. Run away, right? Still shoots, but he runs away. Okay, put him out of his misery. Range on these. Okay. Now, any questions? Anything out of left field? Okay, keep working on your project if you're not. If you're already in great shape and you're looking for new crazy stuff, then we can keep doing it. All right. Last and certainly but not least, and we'll talk about this some more, but it's a really great one, especially if you're going to not come to class on Tuesday and won't see you again until next week, until next Friday. Who knows? But this is one worth looking into, and it's not that difficult to do, but it opens up a tremendous world of things. And this is that in starting with Unity 2019 and 2020, there's a real 2D renderer. Now, what we've been using up until now, you ask, well, what's the renderer? What is this about? You know, we've seen the sprite renderer on the actual objects and so on. But what is this with other render? Now, the renderer is really what's responsible for drawing everything in the game. And it combines the materials, and what a material is what, you know, how we actually draw a particular object, or, you know, there's a whole bunch of layers here that wind up in. So for example, we have the hero, which has a sprite on it, and the sprite uses a material, which is sprite's default. And you'll see, I may even see some things about the sprite's default material here. So everybody that's a sprite is normally using, say, the sprite's default material. And the lighting is even, and it's just boring and dull and all that kind of stuff, because it's just a sprite's a sprite. You just put it on the screen, no big deal. But now in Unity 2019 and 2020, and using something called either the lightweight render pipeline or the universal render pipeline, depending on what version you're in. 2019, it's the lightweight render pipeline. 2020, it is the universal render pipeline. You want to check in your package manager, go to your package manager, and check in the Unity registry or show all packages, and you can usually find, like you'll see universal RP or lightweight RP. You know, if one of those two are installed, you're in great shape. If it's not installed, you can add it. I think it might be probably just by default, but that's the rendering pipeline that we can use to take advantage of some other things. Don't just run out and check this. This is a good thing to kind of like, because this will affect everything in your project potentially. So be careful. If you're going to submit, if you haven't already submitted your project, watch this again later after you submit your project, or open up a new project and try this out, right? So this is a little bit, we'll call this experimental, but I'll show you how to do it. It's not that scary, but be careful, make sure you're in good shape before you try this. Do try this at home, but not immediately. So you have to go through a few more steps. Okay. Once we know we've got the universal render or the lightweight pipeline, we need to do some things to our project. This is really at the project level, right? So just like our 2D physics, this will affect potentially everything in your project, potentially, unless you are pretty good at managing your materials, right? So a material is determining how a particular object is being drawn. So you kind of burrow down a few levels. This is where, if you wind up taking game architecture with me, or you take computer graphics for games with me, we'll start talking about, how renderers work, how shaders work, and that sort of thing. And those are really the things that ultimately determine how something looks. And even if you're studying computer graphics for, as an animator, as a drawer, as an artist, you've probably seen shaders and materials, right? These are concepts you'll run into, right? So the first thing we need to do is potentially tell the project settings. We have to say, well, graphics, we're going to come up here, and you probably will see none in this, right? You just use the render. There's no render pipeline asset. That means you're using just the built-in defaults. That's what you see. If you say graphics, none, right? That's just the built-in renderer. And what we want to do is we want to actually use the universal render pipeline now that we've included it as part of the package. So let's create I'm going to create, maybe not, we're going to create a folder called pipeline assets. We go in there, and I'm going to right click, and I can say create. And actually, before I get to that one, I'm going to do this. I can say file. Once I have that, now you should see a render pipeline, and we can say generate shader includes universal render pipeline, all of these kind of things in here. Potentially, we're not going to do that, but it's a good way to make sure that you've got the renderer there, right? So we're in project settings. Now we're going to come over here, and I just forget which way I'm doing it. I'm going to say create, and in here we will see rendering as well. Universal render pipeline. We have to create something called a pipeline asset, right? That's what it's looking for up here, this render pipeline asset. That's going to tell it how should everything be rendered. So I do that, and I can just hit enter, and it's actually going to create two files. One is the render pipeline asset, and then the other one is data for that asset, right? So now that I've created that, you'll see there are, over in the inspector over here, we can look and see what they are. And this one references the other one, right? They're kind of a pair, this one referencing the other one. And then we'll drag this one and tell the graphics engine to use this render pipeline asset. So now we're using the universal render pipeline asset. However, and this is where you got to be a little bit careful, we're not using 2D. Nothing will have changed, right? Nothing will have changed in your game. Nobody's looking any different, and so on. So even if hopefully, even if I go to the scene and I've jumped through this hoop so many times, it might be a little bit weird. I think we'll bring in Knuckles. We'll bring Knuckles into the scene. Okay, Knuckles is just normal in the scene still, right? Still sprite default. To make it different, take the next step, is we go back and now let's go back to those settings here, our pipeline assets. And instead of using this one here, we're going to create another create and say create rendering universal pipeline 2D renderer, right? By default, it just created its normal forward render, but we want a 2D renderer. So we'll click in here and it will create a new 2D renderer data, right? Here's the data about rendering. And if we come back here and instead of using the, we come back here, instead of using the normal forward renderer, we drag in our 2D renderer to there. Now we are actually configured to use the 2D render, and still not a lot has changed, right? Still not a lot has changed. But you'll notice now if I come and I drag in Knuckles, Knuckles is not colored at all. Knuckles is black. And that is because Knuckles now is using the Sprite Lit default shader, Sprite Lit. So Knuckles now can receive light. Let there be light. Now we have to put some light in, right? So if you don't have something that's lit, it will be in darkness. So we can create 2D, and I'm just going to create a global light, right? And I can increase and decrease my global light so that is also known as sort of like ambient or global ambient light. So just to give all sprites a little bit of light. And then I'm also going to create a light that is a 2D point light. And I'm going to put it over here and maybe increase its intensity a bit. Let's see, I want to shrink down the inner radius, change that, turn up its intensity, and so on and so forth. And you'll see now that Knuckles will be lit depending on Knuckles' relationship to that light. Potentially very cool. Now, I think I actually do have, already have a point light in my scene. I'm going to put this one on there. The nice thing about this point light, I'm going to turn this one off, is that I put a little gem where the light is. And that gem doesn't do anything. It doesn't create any light. It's just a reference so I know where that light is. So if I click on Knuckles and I move Knuckles around the light or away from the light, you'll see that Knuckles is lit. So say I have other things in my scene that I now want to use lighting with. So I'll go ahead and I'm going to use my hero here. And you have two options. You want to convert everything. You want to take the plunge in a real big way. You can use these sort of built-in upgrade everybody, 2D render, upgrade the whole scene. I'm not going to do that because I don't want to upset everything yet. I'm just going to upgrade our hero here. So I'm going to go over here and I need to use a new material that knows about that. Now, so what I'm going to do is I'm going to go back to my pipeline assets and right click and create. And I'm going to create a material. All right. So it's a new material. This is going to be my lit sprite, just because. Now this comes in handy if you're working with legacy sort of things, right? You may need to say, all right, the shader I want to use is a universal render pipeline 2D, universal render pipeline 2D sprite lit default shader, right? So that's handy if you're going back and forth. If you just did everything from scratch here, notice Knuckles did the right thing because Knuckles is now a modern, he's thoroughly, he's using a universal render pipeline shader already because he was created after the big switch. There's things before and things after. So because I want to do this sort of incrementally, I'm going to now use this other shader that I created. And you'll see I have my lit shader. I also have an eraser mice lit shader, whatever. And I can use those to kind of go in between world. Now, this character is going to use the my lit sprite. And you'll notice the further away from our light it goes, the more lit it is. So this is dynamic. I can wander around my scene. And if I wanted to have shadows everywhere, and I could, go up to this light and so on, right? Do cool stuff like that. Wander around. Here's Knuckles over here. Knuckles isn't seeing much of the light. So let's move Knuckles closer here. Now, another cool thing that can happen is you'll notice if we look real closely here, let me drag this, make it bigger, is that the hero is actually casting a shadow on Knuckles. And to make that more obvious, I'm going to turn down the intensity of our ambient light. Right? And, I needed to move Knuckles too. So again, if you're working on your project, tune out. Don't listen to this. Worry about your project. If you're not done with your project, worry about your project. If you're done with your project and you want to learn new stuff, then pay attention. All right. Come back to this later. So we'll put Knuckles right at the edge of this light. And we will move the player around again. So we see the player gets into the light, and then the player casts this cool shadow. So how does that work? How does the player get to cast shadows now? Well, we have to add another fun thing, which is called a shadow caster. Right? So the hero didn't do it automatically. It's something you add like another component. It's just called a shadow caster. And you say, okay, cast shadows, and it has a shape. And the shape can be as simple or as complicated as you like. All right, so if I say edit shape here, that's backwards. So I can move the shape, make it bigger, make it smaller, make it fit, whatever it needs to be. And that's the boundary then that the shading engine will respect with regards to lighting. That's one part of it. This is why lighting is challenging. The other part of it is you need to go back to your light, which is going to be our point light here, and tell it that the light will interact with shadow casters, right? So now I'm cranking it all the way up here. And now in our scene, we will see, we'll cast a much darker, much crisper shadow across. Even if we're walking on them, it'll be kind of cool. You can have it cast shadows on itself. You can have it, all kinds of neat things. So lights can be attached to objects. They can be, you can move them around. Like say we wanted to have this light here instead of being there just in the scene. And what we're going to do is we're going to grab that point light and attach it to our hero. And the first thing I always like to do is to make sure when I do that, set this to 0, 0, so that it's moving with the player. And now the player will illuminate the scene as it moves around. That's a little bit weird. In this case, you'll notice it's never, what I've done here, here's a bad idea. What you don't want to have happen is put your light inside of a shadow caster. Because guess what? It's like appearing inside the wall, right? So we're going to go over here, take our hero, and disable our shadow caster. Right? If you're holding the light, you shouldn't be casting shadows, or else you're basically throwing a blanket over the light. Okay, so now you can move around and shed light on things. Let's go one step further. I'm going to say, all right, I'm going to grab that background tile map, and I'm going to go to the tile map renderer and tell it to use my lit shader. Ooh. Ah, come on, everybody. Ooh. All right. Suddenly your 2D games like just jumped up a whole nother level, right? You're thinking to yourself, hey, now this is on a whole new level. Okay. Now it's full of mystery and intrigue and oozes, totally interesting, right? You can do things like, say, put another point light somewhere. We'll put that one over here. And we'll make it fall off. We're going to make it smaller. Less intense. Maybe the fall off should be a little bit more. Put torches, have them animate them so that their intensity goes up and down, animate their color so that they flicker red and orange. They add, right? So you get closer, suddenly you can burn out that little, right? Scare away everybody. Right. So don't destroy your project you're about to submit. Be careful. Try this. Don't even sandbox. This is something it will impact your whole project. So unless you're experienced, unless you're feeling like, yep, I've been waiting for that new thing that I haven't done at all, open up a new Unity project, save that, experiment with it over there. And then when you're feeling a little bit more comfortable and you want to try to go, maybe add some 2D lights to your game, then get there. All right. So something to do on your wellness day off. If you've done everything else, open up a new project and play with things. And the 2D lighting is definitely one to play with, because it's definitely takes 2D to a whole nother level with regards to the look and richness that you can achieve quite simply. All right, it's 11:31. Thank everyone who stuck with it here, and there weren't a lot more questions. I don't know how. I mean, even though the project is due tonight, there's no guarantee. I think I have an appointment this evening from 7 onwards. So how interactive I'm going to be past then. If you do have questions, get them in sooner, even if it means, tuning in during the next class, or, if you have some question we didn't answer now and want to help, throw a question out for the next class and stop by as that class starts. That's always cool too. Don't skip your other classes, do that. Yeah, counting on me being around after class on a Friday night. I'll try, but I do have, like I said, I have an appointment. It's normally like a 7 to 10 kind of thing. And usually I like to get to bed at a certain reasonable hour. So be careful. That's why you're supposed to ask questions earlier. I'm wagging my finger at the camera and I'm not, let me show my face again here. All right. So be careful if you are going from the tutorials and other things and so on. Don't just copy lots and lots of code, assuming that everything is vital and necessary. I've seen situations where, like, someone is asking for help, or and there's like some weird feature or something that's referenced. I'm like, well, why does your hero have, like, is it, why do you have a power pellet thing that's not even in your game? They're like, oh, well, I saw that it was part of a script in the whatever. Don't blindly copy. Even if it means, like, come and ask me what was I doing there, or what was in that script and so on. Try to pay attention to where I am, what I'm accomplishing. Don't just add everything, every line of code that you may notice in a particular video or a freeze frame or something like that. Be very careful, because more often than not, that'll just add confusion when suddenly like, oh, null object is found, or I'm trying to reference a animator parameter that doesn't exist and so on. That's because you kind of copied it exactly from the video, right? Careful of that. Okay, what about lighting sources of different shapes? Is that possible? Absolutely, yes. You'll notice in here, so last but not least, as I was adding lights into the scene, there's a bunch of different ways you can do that. There are other lights. Everything is sort of everything has, you start off with everything is either a directional light or a point light, and then everything's sort of fine tuning after that. So lights, 2D. There are parametric lights. There are sprite lights, which will basically be sort of masked lights. You have the global light. You have freeform lights, which are kind of cool. So here's a square light. So if I want to light a square area, rather than actually, say, use a mask or use the shadowing, right? Because I can always, if I had the character down here, say I have on my grid or something. Yep. Oh, did it again. Thank you so much. So I just threw in a, what did I throw in? A freeform light, which happens to have a square shape by default, but I can, add points. And it has a drop off at its boundaries. And so you can do this, or you can always say I was creating an empty object, and that empty object has a shadow caster on it. Right? You'll see everything behind that object is now cast in shadows. I might need to say cast self shadows, in which case now it's an invisible object that casts shadows, so you don't see anything on the interior. And I can edit its shape. So if I wanted to, if you have an object, if you have a tile map or something, chances are you're going to put a shadow casting, a shadow mask on that. And yeah, it's pretty cool. It's a lot of fun. 2D lighting is very, like I said, it gives you, it's a whole nother sort of level to how things look, definitely. Suddenly you're like going from like 8-bit, 16-bit up to, 32-bit games. It's like the first wave of, seeing something on an N64 versus on something prior to that. I think it's a lot of fun. All right, everybody, have a great weekend. I'll be seeing you on and off, but probably not until next Friday, I guess. Happy Wellness Week, or whatever we want to call it. Happy spring break that's not spring break. I'll just keep churning out fun stuff. And do think about the design of your platformer, right? You've seen Donkey Kong. You've seen you've seen Sonic the Hedgehog. Any, think old generation systems, 2D platformers, design around that. Think of crazy mechanisms you might want to have, different devices and so on. So think about your design. Let's see. Another quick question. Can I just leave lists of destroyed game objects be? I have like a burst shot script that creates a list of projectiles every time it's invoked. I feel they won't clog up memory too much, so I don't plan to write ways to remove those lists. The lists themselves are the objects. If you've got lots of objects that stay around forever, that's potentially a recipe for disaster, especially bullets, right? If you're going to some bullet hell game and you wind up with too many things around there, that can potentially be kind of crazy. The lists themselves, well, you can always just clear the list once there's nothing in it. Well, if there's nothing in it, you don't really need to clear it. So are they're within a certain script, or? Yeah, I think that sounds fine. I don't think, I mean, off the top of my head, having a couple of lists around that are kept for maintenance, if they're empty, Yeah, that's fine, I think. All right. When in the animator, what can we do to force an animation to finish playing completely? If you want it to finish playing completely before transitioning to another video, to another clip, okay. Let's go back and we'll click on the game object here. Obviously, if you just stay in an animation state, it'll just play forever there. But say that this walk front will make that the layer default, or we have a transition to there. All right, I'll make this the default again. So if I want this one to finish playing before going to this one, right, then this transition should say has an exit time, and the setting should be, say, either 100% or 1 there, right? That means if the exit time is 1, that's a normalized, that should be a normalized time. It's going to say play out the whole, say it has a loop time of 2 seconds. It should play the whole 2 seconds before trying to transition to something else. All right, if you only want it to play once, you only want a certain animation to play once, if you find the animation, find the animation that you created somewhere in your assets and tell it to not loop, okay, then that will cause it to play and stop. All right, so you have that possibility as well. But if you only want to, tell it, make sure only play through this, or make sure you don't transition until you've played through all the way once, set the exit time. You could also, let's see, is that in seconds? Yeah, you would want to combine the two is a little bit weird. So I would say just use use exit time to 1. I'm going to stop the YouTube stream there.